Hello guys, welcome back to my channel. In this video, I will explain you about my recent project that is store sales prediction. This project I can worked it on my lab session. You can also see that, and this is actually a Kaggle project, or you can say Kaggle competition. How I converted this competition into a end-to-end project. Let me explain with it. So this is my project. So we have two CSV files. One is train.csv and another is status.csv. This is a regression problem. So we have to predict our item outlet sales, which is our numeric variables for our test.csv. So let me give you the overview what we have to do. First, uh, first we will import our own CSV files in our Jupyter notebook. Then we will do data cleaning. In data cleaning, we will first check for is there any null values. If there are any null values, how we will handle it, or we can say how we will fill it with mean values or median value or any categorical value. And then we check for duplicate value. If there is any duplicate value, we will drop the duplicate value, and then after we will do EDA and then visualization. And after visualization, we will convert our categorical variables into numerical variables and start training our model. Then we select our features which are more correlated, or we can select our features the most correlated ones, and we can drop least correlated variables. And then we split our data into independent and dependent variables. And our next step is splitting our data into training and testing set. We take one part for training and another part for testing. And then we perform standardization, or you can say normalization. Uh, then we train our model, and then we will perform hyperparameter tuning. Then we save our model, and then we predict value for trained.csv. Uh, Here you can see we predict for this value, and then we create our Flask web app for this project. And then we create a front end, or you can say front end page for this app. Let me go back to my notebook. This is my notebook or IPYNB file. So here we initially imported our necessary libraries, and then we imported our trainer.csv file as a df. Here you can see. In next step, we imported our test.csv file as test using pd.readcsv function. Here we are checking for the shape of data set. Here we are, you can say, printing all unique columns inside the data frame. And then for data set information, we use df.info. Here you can see item identifier, item fat content, item type. These all are of object type, and other are of float 64. So our first aim is to here you can see our importing part is done. Now we have to check for null values. Is there any null values? Yes, it has null values. Null values in item weight column and outlet size column. Let me see. You can see here outlet size column is of a data type object. So let me see what are the unique values inside this outlet size. Here you can see we have four values. One is medium, high, and small, and any is for the this is empty value. Okay. So now what we doing? We are filling inside nan value nan as a text. Here you can see it is a text. So let me run this. If now we will see, yes, this problem is solved. Now we have just item weight. So what's the data type of item weight is in float type. So let's see. We can fill a median. Let me take item weight medium value. Here you can see 12.6, and let me see mode and also mean. Here you can see we can select the median value. Yes, median value will be good for our model. Let Now we are filling NA with for filling NA values we have a command like for first select the column like I have to fill for item weight item weight, then method is fill NA means fill my NA value. Okay, and now I have to type value. For what value I want to insert my item weight median value dot median method. Now you get this series, but this value not saved in item weight. Let me For that I have to save this in df of item weight. Then let me run this. Here you can see we do not have null values. We solved this problem. We can also write here done. Now we will check for duplicate values. There is no duplicate value. Let's see if there is any duplicate value. It will drop that duplicate value. This part is also done. Now we will perform EDA. Now we are exploring our data frame. So now what I am doing, I am taking the all object type columns and finding the what unique value inside these object data type columns. Here you can see I created a for loop for call in df.columns, and if d type of column is equal to object, then print the column name with df of call dot unique. This will give me unique values in my column, and then length of df call dot unique. It will give me the length or you can say number of unique values inside column in this call column. Here you can see in item identifier we have 1559 unique values, that is FDA15, DRC01, like that. In item fat content we can see we have 5 unique values: low fat, regular, low fat, LF, reg. But if you know, these low fat and LF has same meaning, so we have to you can say clean our model, or you can say we have to create a single value for all three LF, and for regular and reg we have to create another value. In item type we have 16 unique types. Okay, in outlet identifier we have 10 unique outlet. Okay, in outlet size we have 4 unique values, and in outlet location type we have 3 values. Cool. And in outlet type we have 4 unique values. So our now first aim is to we are dropping unwanted you can say row, unwanted column, because this has uh, uh, around 1500 unique value, and this is of no use, so we are dropping this. Now we can see in our data frame this is dropped, and for dropping the column we have command df dot drop, and here write the column name, something like xyz, uh, xyz, and then if it is a column, then we have to give axis as 1, and if it is a index, or you can say row, then we have to give values as 0. Okay, so now we are solving this problem, that is converting reg into regular, and low fat into capital low fat, and lf into low fat. So for that I will use the replace method. I have to replace reg with regular. And here you can see when I type dot unique, uh, reg is gone, and we have just regular. See, in similar way, I use here replace LF with low fat, and small low fat with you can say capital low fat. And if I now use a unique command, then you can see we have just two unique variables, two unique values, that is regular and low fat. df dot describe is for describing numerical variables. Here you can see we have mean, standard deviation, minimum value, maximum value, 25 percentile, 75 percentile, or you can say median value for every column. So now what we want, we have an column name outlet establishment year. So we can convert this column, or you can say we can create new column using this column with the outlet age. So we are creating this new column outlet age with using this column equal to 2023, that is present year, and minus uh, outlet establishment year. Let me run this. You can see we get our new column, that is outlet age. So now we do not need this column, so we are dropping this column, and we are checking for the unique values of item type. Can we you can say combine this in categories, but we can see we cannot combine this in a single categories. Import warnings dot warning filters dot ignore is for ignoring the warnings. Item weight distribution. So now we are heading towards visualization part. Then say this is also done, and now we are on visualization part. Here we created some visualization. Like now we have created a histogram of item weight. Okay. Then we create a count plot of item fat content distribution. Here you can see it. We have more values of low fat, or you can say more items of low fat. Now we are creating count plot of different categories. Then total outlet sales by outlet identifier, that how many sales each outlet has get. Then we created outlets. Similarly, I created for total outlet sales by outlet size. Here you can see we got our visualization. Then for total outlet sales by outlet location type, total outlet sales by outlet location type. Here, then we created a box plot. Then we created a pie chart. Uh, And for creating box plot, we use sns dot box plot, and then inside our data we give our data frame, that is df, and inside x we defined our uh, column name, that is item mrp, and here you will get our you can say visualization. And for creating a pie chart, we need prt.py, and here we have to give the values like what we get. Let me explain. Here you can see, here we get the values of for giving this. Uh, Here we have to give the values, and for labels we can just type dot index in after that, and you can see we get our indexes. Here use dot index, and then auto pct4 this, like I want this in my one decimal when value for after decimal. This is just for angle. Let me run this. Then we created bar chart for outlet size, and then plot, violin plot, then stacked bar plot for outlet location type and outlet size. Here you can see. Uh, Now I'm trying to create a heat map. But if you know that for heat map of correlation, but uh, correlation is can be find only of just numeric variables. It We cannot find correlation with the categorical variables. So now we are creating a list calls, defining a empty list calls, and saving uh, column names which has numeric data type. For that I use for call in df dot columns. If df call dot d type not equal to object, then I will append that column into calls list. So I run this and I get all the column names. So this column list I will give to df and use dot core method, and this will give me correlation. Let me run this. Here you can see I get the correlation, and this I will save in a core variable, and then uh, for heat map I use sns.heat. Inside data I give core, and annotation is equal to true, and here I get my visualization. You can see item outlet sale is more correlated with item MRP. Correlation is 0.57. Similarly, we as we defined a column without object data type, now we are creating a empty list obj, and here I want to save my column name which has categorical data type, that is of object data type. So similarly I created a for loop for call in df dot columns. If df of call dot d type is equal to object, then append that call into object list. And this is I'm performing for one hot encoding. Oh, so our visualization is done, and now our aim is to converting categorical variables into numerical variables, or we can say we are performing one hot encoding. So for one hot encoding, we are using uh, pds dot get dummies function, and we have to just give our data for which we have to, you can say, create dummies. Here we are also using drop first for dropping our first column. of every category, and then dot as type integer, because this will give us a true and false value, but we want our output in 0 and 1. Here you can see we got our you can say one hot encoding value, and this will be this we will save in OHE variable, and now we are concatenating this with numerical data, or you can say our numerical variables. Here and if you know, we saved our numerical variables in uh, columns list. Let me see. Here you can see these all are our numerical variables. So we are creating a new df, defining a new data frame, that is df1, and we are our two data frame, that is one with one hot encoding and another with this numerical numerical variables, and saving as x is equal to 1. It means I want to save it as, or you can say concatenate using by column basis, not in row basis. So we check the shape, yes, it is correct. And df1 dot head, let me run this. I think which is not defined. Let me run this. Okay. Now one hot encoding is also done. Now our next part is features selection. This will do after some time. First, we will split our data into independent and dependent variables. Now, if you can see our data, our independent variable, all are our independent variable, and one is our dependent variable, that is item outlet sales. So if we drop this column and save that entire data frame in a new data frame, then it is it will save all our independent variables. So we are doing the same. We are taking df1 dot drop what we are dropping, our target variable, that is item outlet sales column, and 4x is equal to 1. It means it is our column name, and if we have to remove index, we have to use x is equal to 0. This I am saving in x variable and then running it. Nice. Now I have to you can say define my dependent variable. I am defining my dependent variables as y, or you can say small y. Small y is equal to df of item outlet sales. I will run this. This part is also done. So my next part is splitting into training and testing set. So for that I used train test split from sk.model selection library. I defined xtrain, xtest, ytrain, ytest, and train test split x comma y comma test size equal to 0.2, and random state. You can give any value here. Random state is just to if you run this command multiple times, it will split our data in same manner, not in different manner. Random state is to just purpose of random state is just this. So we splitted our data. Now we are performing normalization. For normalization, we are using standard scalar. It is in sklearn.preprocessing. First, we initialize this scalar is equal to standard scalar, and then we fit it for our xtrain data, and then transform or you can say transform our xtrain and xtest. So for fitting and as well as transform, we use fit underscore transform on x train and save this into x train scaled variable, and just we have to perform scalar dot transform into x test. So we run this command. Here we get our you can say scaled value. So this part is also done. So now we will train our model. I have a, you can say, I have a, you can say train many models, but I get maximum score, or you can say accuracy score for this gradient boosting regressor. So I selected this model, and for this hyperparameters, where my loss is squared error, learning rate is 0.1, and my criteria is squared error, and n estimator is 15. So this is my hyperparameter tuning, you can see. So our model training is also done, and hyperparameter tuning is also done. So then I will initialize this, and then reg.fit, I train my model, and then reg.score for scoring, for checking accuracy score. And now what we are doing, we are if you say df1, we what inside df1 we have all variables, including independent variables and dependent variables inside our df1 data frame. Let me show you here. df1 dot head. If you can see, we have 38 columns. So we have our dependent variables as well as independent variables. So what we are doing, we are creating a correlation metric. We are finding correlation between dependent and independent variables. If it is if some features, or you can say variable have least correlated, we will discard that. And now we are, you can say, we are doing feature selection. So now we are doing this part, that is feature selection, and training our model for you can say top 20 features, and then we will train our model for just top 10 features, and then we will see how our accuracy score will affect. So for finding correlation, we have tf1.core, and that we saving core y. Now we are selecting just top 20 features for. So if you see core y, it will give me this, but I want just correlation with my, you can say, target variable. My target variable is item outlet sales. So if I int item, or you can say item outlet sale, but if you know, here in correlation, negative value means it is negative correlated, or you can say negatively correlated, and positive means positive correlated. We just need an absolute value. For here you can see I get all values as positive. Then I will sort these values in descending order. For descending, I have to use descending is equal to false. Here you can see my all values are now in descending order, and irrespective of you can say sign, because we use absolute value here, and we take just we have to take just 20 features, so we use just 20 and save this in a new variable, that is top 20 features. Then we created a new data frame with just 20, that 20 features, and here you can see this is our data frame. And now we are doing same thing, splitting into independent and dependent variables. Then we are splitting it into training set and testing set, and then we will training our model for this uh, you can say these features, and then we are checking our, you can see, score. Here you can see we are getting around 0.609, and previously we are getting around 61 0.6104. So there is no such a gap, or you can say no such drop in our model score. So now what we can do, we can do the same thing for top 10 features, and let me do again, and then checking the score. Here you can see it will drop to 60.89, which is not, you can say, we can use this feature, we can use this model because our accuracy score is not dropping as much, as higher. We can see it is of around 1%, which is not a big deal. Now we are for now we want to save our model. For saving our model, we are importing pickle, and for saving our model, we will use it with open. Uh, Here you have to write the name how you want to save model.pkl and web as f pickle.dump. What you have to dump, you write your model comma f. Here you write, and also we want a scalar, we have to save our scalar also, because when we create our web app, we need for pre-processing we need this scalar. Then again, so now let me check, this part is also done. We save our model also. Now our aim is to predict our value for test.csv. If you can see, we have this CSV file test.csv, and we have to predict value for this data set. First we have to, if you can know, if you know, we initially imported this data frame as test. So I'm just doing nothing, I'm just copying this data frame, test data frame, and saving it as test1. And here you can see test1 is equal to test.copy, and we have to perform the same process, the entire process, like check null values. Then if there is null values, we will fix this problem, and then we will drop duplicate value. Then we will perform EDA, or you can say data cleaning also. Then we again convert the categorical value into numerical values for this also. So here you can see we are filling and null values. Also there we are filling null values. Now we are dropping our item identifier column. Now we are replacing LF with low fat and small low fat with capital low fat. Here we are replacing reg with regular. Here also we need to create a this you can say new column, that is outlet edge. We have to do you can say all the step as we this do it for DF. Here we are dropping this outlet establishment column also, establishment here also. Again, we have to perform one hot encoding for this. We have to remove this column, concatenating. Now we are you can say we are concatenating one hot encoding data with remaining data set. And now what we are doing, we are just taking that 10 top 10 features which we have saved, which was in IND4. You can say we have top 10 variables. Again, we are for performing normalization. For this, we will use scalar.transform on test 3, and which we saved in the test 3 scared. Now we are predicting the value and save this into test predict is equal to reg is our model dot predict dot predict is our function, and test 3 underscore scared is our you can say x value for which we have to predict. And now our main aim is to concatenate this, you can say this value with our test.csv. So first we converted this into a new you can say data frame that is predict, where data is our test predict and column is item outlet sale, and then concatenate our test.csv file with this data frame. Here you can see test comma predict. Here you can, now we are saving our CSV file, so which we got here. You can see here we got this column with predicted value. Now our this step is also done. Now our step is to create Flask web app. For that we have to create a file app.py. Let me show you how we want our web app. You can see here you can say I want to create this web app like Big Mart sales price prediction. Here it is item identifier, item weight, this all columns, and there is a submit button. When I hit submit, I will get my prediction like this. And there is also an home button, which if I will click, I will go back to this page. So for that, for Flask app, let me import Flask render template request redirect and URL for. We need a numpy also, so we imported numpy, imported request, imported pickle. Pickle is for loading our model which we saved in this file model.pkl and scalar.pkl. So for loading the file, we have to just use pickle.load and open model.pkl. Then we are starting our, no, we have to initialize our web app here. App is equal to Flask underscore underscore name underscore underscore, and also we have to do if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, then we have to give app dot run. And this is for when we deploy it on any cloud server, but here you can use debug is equal to true if you have to run locally. If you can now we are creating for home page app dot route, we have to route for that single slash, that means it is for home page. Define home, return what we have to return, render template, which is template that is index.html, which is this template index.html. Okay, so when we hit submit button, what we get, we get a request.method is equal to post, and we will define our values, or you can say using request.form item MRP, we will load our values, and like if you can see here, item weight, it will be of float type. So initially it is in text string. If you can see it here in index.html, you can see here item weight. Its type is string, but now we are converting this into float value. Similarly, we do this for all you can say variables, and then we will create this convert this into a numpy array, and then use dot reshape 1 comma minus 1, and for pre-processing we will use scaled is equal to scalar dot transform and transform this value. And then for prediction we will use prediction is equal to model dot predict. Predict, for what we have to predict, we have to predict for scaled value, and for rounding our value we use our round function. And what we have to return render template prediction.html. Here we will give result is equal to prediction. Let me show you what this result variable means. Let me pull prediction.html. Here we write your total item outlet sales is. Here I give the result, you can say, as a variable. So what value it will get here, it will show me here. Let me open this. What value I give this result here, I will print it here. So that's my web app. If you see, we can also run this. I think it will take some time. Here we go. My web app is running. Here you can see we can find our prediction. Let me hit submit button. Here you can see I got my predicted value. So for closing my web app, we can use Control+C command. Here you can see. And for deploying this web app, you can follow my live stream that is on day 3. I will link down that I will link that live stream link in my description. Okay. Thanks for watching.